All right, this is number 2 from this practice test. And it says, what do they tell you? They say the perimeter of ABCD is 44. So where's ABCD? Here's A, here's B, here's C, here's D. But what are they talking about? They're talking about this quadrilateral, right? A to B to C to D, and then back to A again. Do you see? It's a four-sided figure, isn't it? All right. In fact, let's see if I can do this. I don't know if it'll make it stand out anymore or not. Let's see. Click that. Okay. And let's just make it a little bit thicker. There we go. Now it stands out a little bit, doesn't it? So what we want to do is they tell us the perimeter of this thing. I'll just put P. Whoops. Let's go back to the smaller size. There we go. They tell you the perimeter is 44, and they ask you to solve for x. That's what they're telling you right there. So when they say when they say the perimeter, what are they talking about the perimeter? The outside, okay? If you add up all the outside lengths, right? So look at the lengths. I got 4 sides, I got 4 lengths, don't I? This is x plus 5, 2x minus 7, x plus 1, 2x minus 3. So the perimeter means if I add up all 4 of those things, that's going to equal what? You guys paying attention? Up here. Nobody, you're not focusing. Let's look up here. Let's pay attention. The perimeter means you do what to them? Add them up, and then you set it equal to what? 44, because they tell you what the perimeter is, right? They say if you add up all 4 of these things, that adds up to equal what? 44. So let's do that. Let's add them up. It doesn't matter what order you add them up. Let's just start with this one. I've got x plus 5. Let's go to this one. I got a 2x minus 7. And I add it to this side, which is an x plus 1. Whoops, forgot the plus in there. And then you add it to this one, 2x minus 3. All right? Now, if I add all those up, what should it equal? 44. That's right, because it says the perimeter of this thing right here is 44. Does that make sense? All right, so let's just add them up. Let's count up all the x's. Add up all like terms first. X plus 2x is 3x, plus 1x is 4x, plus 2x is 6x. All right? Let's do the regular numbers. Add those up. 5 minus 7 is negative 2. Negative 2 plus 1 is negative 1 minus 3 is negative 4. Okay? And that's equal to 44. Everybody with me? Just added like terms. Add a 4 to both sides. 6x equals 48. What's x? Right, divide both sides by 6, and x is 8. All right? That's it. Yep.
You did all that work. Wouldn't you just do like 2x minus 3 equals 2x minus 7?
2x minus 3, what? Minus or equals, what'd you say?
Well, like, can you just
take 2 of them and 2 and just figure out what x is.
Like, what would you do to them, though?
Like, x plus 5 equals 2x minus 7 and solve it.
2x minus 3 equals 2x minus 7? Is that what you said? I mean, I'm saying, is that what you said to do?
No, we'll just aim. It doesn't matter.
You're saying just pick like 2.
I know, do what to them? I'm asking you, do what to them? That's what I'm asking, okay? When you say just do the algebra problem, am I adding them together? Am I setting them equal? Am I subtracting them? Am I multiplying them? What am I doing? You said set them equal to each other, right? That's what I'm asking, okay? Well, I don't know. Can you? Watch. 2x minus 3. You said set it equal to 2x minus 7. You said any of them, right? Okay, go ahead and solve for x then. You can't. Right? See, that's a 0, isn't it? And that's a 0. That means, does negative 3 equal negative 7? Of course it doesn't, okay? Now look, let me ask you this, okay? Why could you? Where does it say that 2x minus 3 is equal to anything in here? It doesn't say it anywhere. Let's stop the nonsense, please. No, you didn't. No, you didn't. You're just making noise just to be obnoxious. You're doing a great job at it. Blake Noonan, for all the world to hear. Okay, watch. Look, you don't know. Listen to me. You do not know, right now anyway, that this is equal to this. Now, and that's right. There is no way. I was trying to think of maybe a way that you could figure out that they are equal to each other. There's not. You do not know that this is equal to this. You don't know it. All right? Now, if I did set them equal to each other, that would equal 8. But you don't know that this is equal to this. And you're like, Yeah, but it works. Who cares if I know if I don't know? Well, you got to know. All right, you can't just guess that this is equal to this. You can't do that. You can only go by the information that is given to you and that you know by theorems and all that kind of stuff and rules. You can only go by the rules. You can't just look at something and say, well, sure, it looks like it's equal, so let's set them equal. Now, I'll tell you, you might get away with that every once in a while, but it's not always going to work. So I will never say, oh yeah, go ahead and just set them equal to each other. You can't, because you don't know that that's equal to this. Now, with that said, this actually is equal to this, but you can't tell from the original information. So I don't want to tell you to set this equal to this. I don't want you to tell you that. Look, they tell you the perimeter for a reason. Every single problem, when they say the perimeter is something, automatically I'm thinking, okay, add the sides up, set it equal to what the perimeter is equal to. That's what I'm thinking. All right, you can't just say that this is equal to this. You follow me? Now again, like this is for the second time now, they actually are equal because watch, if I know that x is 8, let's throw in an 8 for this. What's 2 times 8? Minus 3 is 13. Let's put the 8 in for this. X plus 5 is, or 8 plus 5 is 13. So yes, they are equal to each other, but you can't just look at it and say, oh, they look like they're equal to each other, so let's set them equal to each other. All right? That is not a good philosophy to have when you're doing geometry. All right? I'm telling you, I've told you from day one almost, since we've been doing all these shapes, that you can't just do that. Look at this right here. Let's put an 8 in for this. 8 plus 1 is what? 9. Put an 8 in for this. 16 minus 7 is 9. So are they equal to each other? Yes, they are equal to each other, but you can't tell just from the beginning. How did we get the 8? We didn't get them equal to we didn't get an 8 because we set these equal to each other. All right? We got the 8 because we knew the perimeter, and we can add the 4 sides together, set it equal to 44. That's how we got the 8. We got it legitimately, okay? We got it the correct way. And you're thinking, well, I don't care what he says. That's way too much work. I'm just going to set this equal to this. Well, beware, because you never know. You don't know that this is absolutely equal to this. Have I said that enough? Okay. I think I've said it plenty. So I just want to get it through to you that you can only go by the information you've been given. You can't just make up stuff and say, well, it sure looks like it. Okay? All right. Sorry to be so harsh on that, but you know how it goes. All right. Oh, I got rid of all those numbers. Let's do this. Let's there we go. All right, so we just did number 2. Let's go in order. Let's go to number 6. All right. Yeah. Well, is it up there already? All right, this isn't drawn exactly the way it looks in the picture, but it's pretty close. That's 70. That's 165. This is 2 times z plus 3. And this is x over 5. It's kind of a weird question the way that they put these z's and these x's right here.
What number is that?
Okay, this is number 6. 15. Okay, this is number 6. Now let's take a look. It says compare, or what does it say? Write an inequality relating x and z. So look, this has an x in it, right? This side right here, this has a z in it. I want to relate them together, or I want to compare them. So if I compare two sides, what do I want to show? I want to show that one side is either what? Greater than or less than the other side. Okay, so that's what I'm trying to do. I'm trying to find out, basically, is this bigger than this, or is it less than this, or what? Now again, you could, at this particular problem, just look at it and say, well, this sure looks a lot longer than this one, so that's got to be bigger than this. All right, that's not what you want to do. All right, you guys just want the easy way out. Okay, I want you to do it the right way. It's important to be able to do things the right way and not just look at something and say, well, it sure looks like it's bigger, so that's bigger. That's not what I'm trying to get you to do. And I can see it in some of your eyes right now. Like, I don't care if you tell me to do all those theorems and know all that stuff. If it looks bigger, I'm saying it's bigger. Okay, I'm getting it right most of the time, so who cares? All right, well, that's your problem. It really is. Because you're going to come up, with a problem that it's not going to be right. You're going to look at this, and it might look like it's bigger than the other side, and you might say it is, but with the way the numbers are, maybe it wasn't bigger. All right, so I'm trying to help you out here. I'm not trying to be a pain. All right, I'm trying to help you out and not just go by what looks bigger. So what do we do? First of all, we know this is 70. In order to find which side is bigger, I need to find the angles, and I need to see which one is the biggest angle. So I got to find this angle, and I got to find this angle right here. Well, the first angle I'm going to find is this one. Because look, that forms 180 degrees, doesn't it? So go ahead, Joe, tell me, what is this right here? It's 15 degrees. How'd you get 15 degrees? That's right. It's 180 minus 165, and that's 15, right? And why did I take 180? Because it forms a what? 180 degrees, a straight line, okay? Straight angle, straight line, that's 180 degrees, so that's 15. Now, how can I find this one right here? That's right. Add these two up. So 70 and 15 is what? 85? And then what would that be? That would be 95? Okay.
You could have found that 95 price though.
You could have. You're absolutely right. Tell me how.
Subtract 70 from 165.
That's exactly right. You could have taken 70 away from 165 because remember the remote interior angles add up to be the exterior angle. So you're absolutely right. You could have found that as well. Okay? That's good thing on there. Okay, so now what do we got? We got 15, we got 70, we got 95. Which one's the biggest angle? Obviously 95. So that means which side is the biggest side? Okay, that's the biggest side right there. Okay, so 2 times z plus 3 has to be greater than what? This is the smallest, right? And it's got to be greater than x over 5. That's what it means to compare the two together or relate them. It says, let's see what it says. Write an inequality relating x and z. That's a relationship, isn't it? If you wanted to, you could have written it like this. You could have said x over 5 is what? Less than 2 times z plus 3. All right, you could have done that as well if you wanted to. And either one of those is perfectly fine. That's the way I think I read it off, but you could have written it like that as well. That's all they're asking you to do. It's not too hard, is it? Okay. Okay, that was 6. Let's get rid of that. All right, let's see what we've done so far. We've done 2, we've done 6. Let's go 14. All right, let's draw this thing out. Looks like that. Looks like there's a point up here that goes to here. And then it goes to here. And it goes perpendicular. There and there. Alright, that's pretty close to what it looks like. Was it? I haven't done this one yet, so I don't know. There we go. Alright, let's see what they give you. They say this is P, R, S, T, U, and Q. Alright, it says PU is a median. PU right there is a median of PTQ, triangle PTQ. If it's a median, what does it do? It goes from a vertex, and its median, it's what? Hits it in the middle. So that segment and that segment are equal to each other, right? So when they say that that's a median, line segment PU is a median, that means it splits this into 2 equal parts. David? Oh, that's right. I did say it when I drew it, and I forgot to draw it on there. Thanks. All right, so that's a median. It says UQ is 6, so that's 6. What's TQ? Oh my goodness. That was a waste of. You're absolutely right. That was a waste of all that drawing in there. Yeah, right. If that's 6, then of course that's 6. What's the whole thing? It's 12. That was hardly worth doing, wasn't it? Who asked about that one? Now you don't have to tell me. All right. So there you go. Does that make sense? Do we see that? All right. So that's that was 14. Yes. You got your card? Yeah, you asked about 15, and I'm doing 15 right now. Good. All right, let's see this one. 15. Is this one easy too? All right, and then this. Yeah, don't wake him up, because he'll get all cranky when he wakes up. All right, this is 3x minus 4. This is 2x plus 30. Yeah. Yeah, I can go over 15 now. They let me, YouTube let me go over 15 minutes, so I can go the whole time if I want now, which is kind of nice. But thanks for the warning. All right, that's everything, isn't it? It says if BD bisects angle ABC. Here's BD and it bisects angle ABC. So this and this are equal to each other. All right, so it's bisecting it. It says find the value of x. Now, we have a theorem. If you look in, I forget what section it is. Hope you guys are paying attention over here. Shh, don't say anything to me. You're just being silly. All right? I'm not 80 years old, don't know what's going on, okay? So look. If this angle and this angle are equal to each other, we have a theorem that says this. If you have a point that lies on an angle bisector, does that point lie on an angle bisector?
Yes.
Of course it does, because they just said that these two angles are equal to each other, right? Well, actually, it just said it was a bisector. So, yeah, it's got to lie on a bisector. If it lies on a bisector, then guess what? It's equidistant from the sides of the angle. All right? So if this is equidistant from here to here, what's true about this segment, AD and DC? They're equal to each other. So all you got to do is just set those two segments to each other, solve for x, and then you're done. So 3x minus 4 equals 2x plus 30. This is easy. Subtract 2x from both sides, add a 4 to both sides, 34. That's all there is to it. But you got to recognize, all right, it was easy to do the math, but you had to recognize that they were equal to each other. All right, that's the geometry part of it. All right. All right, so that was 15. For some of you guys, I'm going to have no pity when I start marking them wrong on your test, because you guys, some of you guys are just playing around, you just think this is a big joke, and I'm reviewing for a test. I don't have to do this. I could have sat here and give you a whole bunch of extra homework tonight to do and everything else. I'm taking this whole class period to help you understand what's going to be on the test, and we're going to do this Monday as well. And some of you guys are just playing around and acting like it's no big deal. You think you're big, comedians and stuff. It's not funny at all. All right? I know it's funny. And you're not funny. So there you go. Now I'm funny. Alright. So let's see. This is 16. Looks like this. This one comes around. Looks like this. Nope. I'm not that kind of a funny. I don't tell jokes. Alright, that's 20 degrees. And this one is 23 degrees. This right here is 6. This right here is 6. That's H, E, F, and G. Alright, and it says compare EF to GH. Compare EF to GH. Now when it says to compare, I've already talked about this today already. When it says to compare the two, what does it mean to do? Tell whether they're what?
Bigger and smaller.
Less than or greater than, okay? So I got to see if EF is greater than or less than GH. Now again, if you look at this one, it's not near as obvious as what that other problem was on which side was bigger and which side was smaller. So it would be a lot tougher just to guess which one. So we don't guess. We know by theorems. Look, this side is equal to this side. This side is equal to this side on both of those triangles. And we got an angle in between. This is the side angle side inequality. We just did this the other day, didn't we? Side angle side inequality, which means if this is smaller than this one, right? I'll put 2 arcs there. If this is smaller, then the side opposite the smaller angle is the smallest side, right? It's smaller between the two. So this has to be smaller than this one. We'll call this the bigger one. You understand? And whoops, that was a terrible line, but you get the idea. This is smaller because it's opposite 20. This is bigger because it's opposite 23. It's as easy as that. So what do we say about EF? EF is what? What do we say? We don't say smaller. What symbol do we use? Less than. So this is how you want to write your answer. Now on the test, it'll be a blank answer sheet. I won't have EF and GH sitting right there on the answer sheet. You have to write EF is less than GH. Does that make sense? Because on those worksheets, they always had EF sitting there and GF, and all you guys did was just stick a less than or a greater than symbol, didn't you? But on the test, you need to write EF is less than GH. You got it?
What's the test?
Tuesday.
Tuesday. I've said it every single day this week. Yeah, well, I'll get under his skin in a second. He won't like it, so. No, that wasn't supposed to be funny. Absolutely not. No. I'll give you after school, and then I'll come by and I'll look at you in the window and make fun of you sitting in after school detention. Now that would be funny. See, I told you I know funny. Teacher ever do that to you?
No.
Just a couple.
I'm gonna be the first. This is 12. This is 12. All right.
That's actually 11. On the bottom.
Yes, it is. All right, here we go. And it says, write an inequality to compare angle 1 to angle 2. Angle 1, angle 2. So let's take a look. Here's angle 1, and here's angle 2. So how do I know which one's bigger, which one's smaller? I got to look at the opposite sides. That's right. It's pretty easy, isn't it? Look, angle 1 is opposite 12, which is bigger than 11, right? Because 11's opposite angle 2. So if 12 is bigger than 11, then guess what? Angle 1 is what? Greater than angle 2. So that's as simple as that. And that's your answer. And that's what you would write. You would write angle 1 is greater than angle 2. Getting all this?
What number is that?
That was 17. So I've done them all. All right, there it is. Now look, I did record all this nonsense today, so if you want to look at it, if you still didn't understand some of these problems, go back and look at it. That should help you out a little bit. And the test is going to be pretty much, it's not going to be exactly number for number, you know, every single problem in the same order. It'll be fairly similar to what this practice test is, okay? It's not going to be a carbon copy of it, but it's going to be pretty close to the stuff that's on here. All right, so make sure that you're ready for it. And we're going to review one more time on Monday. But we got to have something to review, don't we? So let me give you something to review. Absolutely. Yeah, I didn't write it down on the initial lesson plans for this week, but they're always subject to change. Call it the practice test, and it's page 381. You're going to want to write this down because I'm going to omit some problems, which means leave out. Now I'm going to let you hang on to that so you can use it to study for the test. No, actually, this thing right here I will collect in a second. Let me just write these things down. Okay, we'll do what I tell you to do. Okay, so let's see. You can omit number 5. It's right there. It's up on the screen. You don't have to do number 5. Let's see.
17.
Yeah, 17, 18, and 19. We skipped that whole section. 17, 18, 19. You don't have to do any of those. And then number 23. Do all the rest, though. Omit means leave out. I said it. Look back on the YouTube. I already said it once. All right, so page 381, 1 to 25, but you can skip all these. Leave them out. 5, 17, 18, 19, and 23. You don't have to do any of those, but do all the rest of them. Page 381, practice test. We'll go over that on Monday, and then we'll take the test Tuesday, corrections Wednesday. We'll review for the midterms Thursday and Friday, which means you should be finding your what?
Test.
Your test. Just your test, okay? Just look for your test, okay? That's all we're going to do. All your old tests. We had a test over, do we call like chapter 0 or something like that? Remember that before we started? See, listen. Shh. Listen. So we have chapter 0. We had chapter 1. I think we skipped chapter 2, didn't we?
Yeah.
All right, then we did chapter 3, 4, and 5.
Yeah.
All right, so that's 5 chapters altogether. So that's what's going to be on the midterm. All right. Now, when you take the final at the end of the year, it's just going to start up from chapter 6. Okay. So the midterm goes to chapter 5. The final exam will just start at 6 and then go to wherever we finish off at. Okay. That's it.